Factoring Quadratics, Part 1. In this video, we'll analyze the process of multiplying binomials so that we can undo it. And then we'll factor quadratics of the form x squared plus bx plus c. And we'll also practice factoring out a greatest common factor, and then further factoring the resulting quadratic. Factoring a quadratic means undoing a multiplication of binomials. So let's go through a multiplication and watch what happens. I'm especially interested in where these constant terms affect the final product. So x times x is x squared, and then I'm going to multiply x times negative 5. So I have negative 5x, and then 3 times x, that's a positive 3x, and then I have positive 3 times negative 5. So the where they're used here is that they multiply to make the last term, and they add to make the middle term. When I finish the multiplication process, x plus 3 times x minus 5, the result is a quadratic expression, x squared plus, well, negative 5x plus 3x is negative 2x, and then 3 times negative 5 is negative 15. And usually I write that as a subtract 2x. So now this is the result, and I want to get back to this. I'm going to use the fact that the constants multiply to make the last term and add to make the coefficient of the middle term. Let's factor x squared plus 9x plus 14. The first thing we're going to do is set up space for our two binomials. And since the first term is x squared, each binomial is going to begin with x. Now I need to find the two numbers that go with x in each binomial. And remember that they're going to multiply to give me 14 and add to give me 9. Now, there are many more ways to add to 9 than there are to multiply to 14. So we're going to start by finding the factor pairs of 14. The square root of 14 is only 3 point something, so I only have to write the first three numbers. Now, 1 goes into 14 14 times, and 2 goes into 14 7 times, and 3 doesn't. So I have two possible factor pairs that would multiply to give me 14. Well, now I just need to check and see what they add to. So 1 plus 14 is 15, and 2 plus 7 is 9, and there's the sum I need. Both 2 and 7 are positive, so it's x plus 2 and x plus 7. Well, now let's multiply it back out and make sure it worked. And when I combine the middle terms, I get 9x. So x squared plus 9x plus 14 is the product, and we have factored correctly. Let's step by step factor the quadratic x squared minus 11x plus 24. We know it's going to factor to a product of binomials, so we're going to start by writing our parentheses that will hold the binomials that we need. And since the first term is x squared, that is, it has a coefficient of 1, it must have come from multiplying x times x. So I'm going to write an x at the beginning of each of my parentheses because that's going to be the first term of each binomial. Well, now we need to look at the last term, 24. The two constants with the x's must multiply to make 24, so I'm going to figure out what are the factor pairs for 24. So I make a little chart, 1, 2, 3, 4. That's as far as I need to go because the square root of 24 is 4 point something. And then I write, well, 1 goes into 24, 2 goes into 24, 2 times 12, 3 times 8, and 4 times 6. And those are all the factor pairs of 24. Now those factors have to add up to give me that negative 11 in the middle. So let's see what sums we have. 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. Yay! It's not negative 11, but since I have a positive 24, I could think of that positive as being from a negative times a negative. And indeed, that's what I'm going to do. So since negative 3 plus negative 8 makes negative 11, and negative 3 times negative 8 makes positive 24, my factoring is done. It's x minus 3 times x minus 8. Let's try factoring where the last term is negative. I know it's going to factor to a product of binomials, so I write the parentheses. The coefficient of the x squared term is 1, so it just comes from x times x. I look at the last term, negative 10, and I find the factors of negative 10. The square root of 10 is 3 point something, so I'm just going to do 1, 2, and 3. 1 times 10, 2 times 5, and 3 doesn't work. Now, if it's a negative 10, one of these two numbers, either the 1 or the 10, has to be negative, and either the 2 or the 5 has to be negative. So the factor pairs include one negative, so we actually have 4 instead of 2. Let's add them up. Negative 1 plus 10 is 9, and 1 plus negative 10 is negative 9. And negative 2 plus 5 is positive 3, and 2 plus negative 5 is negative 3. That's the negative 3 we want. So the numbers are positive 2 and negative 5, and we have factored x squared plus 3x minus 10. Now let's try factoring 3x squared plus 3x minus 60. I hope you noticed that x squared now has a coefficient of 3 instead of a coefficient of 1. Well, we're going to talk more about factoring those kind of quadratics in the next video, but this one has a 3, 3, and 60, and those are all divisible by 3. So before I ever start, I'm going to factor out a 3 so that I can have a quadratic that just has a plain x squared at the beginning. So now after I factor out the 3, what I have is 3 times x squared plus x minus 20. And I'm just going to look at the inside part to factor. Now the first term is x squared, so it's going to factor, keep the 3, and write the two parentheses. And they both begin with x, so there I go. And now I need to look at factors of the last term, which is negative 20. So first let's write 1, 2, 3, 4. Square root of 20 is 4 point something. And then 20, 2 times 10, 3 times, nope, and 4 times 5. Okay, one of these factors in each pair has to be negative. So one way to do it more quickly, instead of trying every possible combination of positive and negative, is to just subtract. 20 minus 1 is 19, 10 minus 2 is 8, and 5 minus 4 is 1. Now that answer can be either positive or negative. The one we have is a 1, so we're looking at 4 and 5, and it's a positive 1. So it's either negative 4 times positive 5, or 4 times negative 5, and the one that gives me a positive 1 is the first one. Negative 4 plus 5 is positive 1. So these are my two numbers, yay, and I can just fill them in. X minus 4, x plus 5 is the factorization. But don't forget to include the 3 that we factored out in the beginning.